nonlinear systems of equations. A system of equations in which at least one equation is non-linear. Non-linear is a non-linear system. They both could be nonlinear, but at least one equation must be nonlinear. So in the previous section, so remember we only solved systems of linear equations. So now in this case, you'll see maybe one linear, one nonlinear, the other one it could be both nonlinear. So we will apply elimination method, substitution, or sometimes we have to apply combination of both. So example of a nonlinear system is, for example, this. So it's x squared minus y equals 4. So number one is a nonlinear. And then x plus y equals negative 2. So this is linear. Also, it can be another example is it could be absolute value must be involved there. So look, this is x squared plus y squared equals 16. That's a circle. That's nonlinear. Also, the absolute value of x plus y equals 4. So in this case, both of the equation in the system, they are nonlinear. So we're going to solve those. Let's talk about all the cases. So the first one is solving systems. It's a nonlinear systems by substitution method. So mostly we apply this one when one equation is a linear, other one is non-linear. So here, so solve. So substitution, we're gonna still do the, make sure as I told you previous sections, so just use the side by side. The first equation is x squared minus y equals 4. The second one is x plus y equals negative 2. So as you can see, number one is a nonlinear, number two is a linear. So linear, we always solve for x or y. So you can isolate x or y, we substitute. So that's your algebraic approach. Let's isolate y here. So the y equals negative 2, and then x move other side becomes minus x. So now we will substitute. This is easier. Because if you solve for x, then you're going to be squared. You have to go a minus b squared, which will be hard. So make sure, slow down and think twice. So it will be more work if you open the square. So this is x squared minus, subtraction always use the parentheses, we're going to distribute. Negative 2 minus x equals 4. Distribute x squared plus 2 plus x equals 4. Then move the 4 other sides, right in descending order. X squared plus x, which is always 1x for the factoring purpose, plus 2 minus 4 equals 0. So this is x squared plus 1x minus 2 equals 0. So now, if you remember the factoring approach, we can use the x method. Leading coefficient is 1. So there's 1 here. So negative 2 on the top, 1. The factors are 2, negative 1. So then here is x plus 2 times x minus 1 equals 0. Use the zero product rule. So the x plus 2 equals 0, or x minus 1 equals 0. Well, then x must be negative 2 That's the first value of x, and the other one x must be 1. That's your second. So now we have a 2x value. So for 2x value, we are expecting 2 corresponding y value. So here we're gonna substitute back here. So for x equals -2, then y equals -2 minus -2, which is -2 plus 2. So the y equals 0. Okay, so that's the first one here. So then this is the first. When x is -2, the y is 0. Well, then for x equals 1, we're going to go back and substitute back here again. So that is a y equals -2 minus 1. So the y equals -3. So this is your second y value. So your solution set is the solution set is, so when x is -2, the corresponding y value was 0. When x was 1, the corresponding y value is -3. So this is your solution set. So this method is especially most of the time we use when one equation is the linear, the other one is the non-linear. So then just okay. So next one we can do similar, but make sure you pause the video and try yourself. So for example, this solve this one. So the first equation is very similar to the last one. X squared minus y equals 0. This is x plus y equals 2. So now remember, we can also isolate x. Well, then it's going to be 2 minus y squared. It will be a squared minus 2ab plus b squared. So it's not a smart way to do it. So isolate y because y doesn't have a power. So we're going to isolate y. So this is now 2 minus x. So we'll substitute here. So right here. Again, careful substitution. Here is a x squared minus 2 minus x equal 0. So this is x squared minus 2 plus x equal 0. So write in descending order, x squared plus 1x minus 2 equals 0. So then factor it. The top is -2, 1. So the factors are, again, it is a 2 -1. So then x plus 2 times x minus 1 equals 0. So then using the zero product rule, x plus 2 equals 0 or x minus 1 equals 0. So the x equals -2 or x equals +1. So these are the two x values, and remember we're going to substitute back here and we will get two corresponding y values. So here let's use, so for this is the main equation we're going to substitute. So here this one we're substituting right here. So for x equals -2, well then y is 2 minus -2. So y equals 2 plus 2, which is 4. Y equals 4. So this is one of them. And for x equals 1, for x equals 1, then y equals 2 minus 1, the y equals 1. Okay? So then the answer is, so this is the second y value here. So then solution set is when x is a negative 2, the y was 4. When x was 1, the y was also 1. Doesn't matter which order you write. So make sure you use this for the solution set, use those curly braces. So this is your final answer. Okay, so these are the two examples. Excuse me. Two examples we use where one equation linear, other one is nonlinear, and then we use substitution method. Next one is how we use elimination method. So when what we do if the both equations are nonlinear. So here is the second objective is solving nonlinear systems by elimination method. Okay, now elimination method mean mostly they look like a standard form. So x must be lined up under x, y under y, and the constant under constant. So here is a quick example. So here is a x squared plus y squared equals 4. And then when you use elimination, write them right above each other. Second is 2x squared minus y squared equals 8. This is second. So this is, look, if the both equations are linear, so you see if you add number 1 and number 2, we can easily eliminate the y. So here, that's your elimination, which is also known as addition method. So this is eliminated. So this is 3x squared equals 12. Then x squared equals 4. 12 divided by 3. And then if you remember your the square root principle, this one here, if x squared equals any positive number k, so the x is always equal plus or minus the square root of k. That's your, if you remember, we solve those quadratic equations by completing a square or using square root principle. So this is the property we're using here. So then x must be equal positive or negative the square root of 4. And then x is plus or minus 2. So we have so you can write here, or you can write x equal positive 2 or x equals negative 2. Okay, so now we will solve for the corresponding y values. Okay, so then let's use the first equation. You can use the first or the second. So I'm going to use the first one. So here's the first equation. So if you look, number 1 from the top is, so since we have two values, we're going to write number 1 twice. So here, so the x squared plus y squared, if you look here, this is the first one here, equals 4. Then we're going to write twice because we have a 2x value, so we solve both. So x squared plus y squared equals 4. So the first one is 4, x equals 2. So the 2 squared plus y squared equals 4. This is a 4 plus y squared equals 4. Move y 4 other side, so y squared equals 0, then y equals 0. So this is your, so when x is 2, the corresponding y value is is 0. That's your second one. For x equals negative 2, well then remember the square is always positive. Well, this is negative 2 squared plus y squared equals 4. This is a 4 plus y squared equals 4. Then move it, and then this y squared equals 0. Well, the y is 0 again, because we're not going to write plus minus 0. Okay, so then the solution set is when x is 2, the y is 0. When x is negative 2, y is again 0. So these are your selection set. Make sure you use those curly braces. This is your answer here. Okay, let's do one more like this, and you can pause the video and try it. Let's pick one from your textbook. For example, here we can do, if you have a textbook, we can do number 25, 26. So let's try those. We can do 24. So here. So try this one. You can pause the video. This is both are nonlinear systems. So both equations, just use the elimination method. So the first equation is x squared plus y squared equals 10. The second one is 2x squared minus y squared equals 17. That's your second equation. So very similar to the last one. Go ahead and pause the video, try it. So use the elimination or addition method to eliminate y. So here, if you go here, so you add these, the y cancels. So then this is a 3x squared equals 27, or x squared equals 27 over 3. So x squared equals 9. Using your square root principle, x equal positive or negative 3. So x is 3 or negative 3. So now let's use, just like last time, we used number 1 and twice because we have 2x values. So write them. So using the number 1, this one here, write that equation twice like this. So first one here is x squared plus y squared equals 10. Write one more time. So this is x squared plus y squared equals 10. So for x equal 3. So this is 3 squared plus y squared equals 10. Well, this is 9 plus y squared equals 10. Opposite of positive 9 is minus 9. So y squared equals 1. Using the square root property again, y equals plus minus 1, because square root of 1 is 1. Okay, so we have a 2 answer here as well. So let's do the other one. For x equals negative 3. Well, the square is always positive. You can say negative 3 squared plus y squared equals 10. This is 9 plus y squared equals 10. Then y squared equals 1 again, minus 9. Well, then y equals plus or minus 1. So this is, okay. So then how you write the answer, the solution, let's try the solution set. The solution set is, so when x is 3, we have 2 y values. So here, when x is 3, 1, or it'll give you 3, negative 1. So we have 2. So that's the first one. When x is negative 3, is positive 1. Also, when x is negative 3, we have negative 1. So we have 4 answers. And that is your solution set here. Okay. Let's use the next problem when you use the combination of both methods. This is solving using combination of methods. So we use the elimination and substitution in both. So let's try it. So here is the first equation is x squared plus 3xy plus y squared equals 22. So then this is x squared minus xy plus y squared equals 6. So now if you look very carefully, so we can eliminate x or y. Well, in this case, I mean, it doesn't matter. Look, x squared or y squared. So if you want to eliminate x squared, well, then they both turn into opposite. So we can eliminate both of them in one step. So, but we have to have opposite signs. So what we're going to do is multiply number 1 or number 2, doesn't matter. So multiply number 1 by, let me use different color. So multiply the first one by -1. So then right below here, so this is negative x squared minus so this is doesn't matter which one you use, but the answer is going to be the same. So let's use the second one. Make it easier because let's multiply this one. So the top one is staying the same. Right here. So the x squared plus 3xy plus y squared equals 22. So number 1 we're keeping as is. Then this one is now negative x squared plus 1xy minus y squared equals -6. So now you can just add both. So if you look carefully, your x squared and y squared, they eliminated. So what the left over here is positive 4xy equals 22 minus 6 is 16. Then divide both sides by 4. Then xy equals 4. Now we can just here, we can isolate x or y. Well then if you solve for x, or x is 4 over y, if you solve for y, which is, so let's solve for y. Y equals 4 over x. So this is the value we're going to substitute here. Okay, so now we can go back to second equation. So substitute y equals 4 over x into number 2, the second equation. So then it will be this equation here. So it's the x squared minus x times the y is the 4 over x plus 4 over x squared equals 6. So let's simplify. This is x squared minus, so this x cancels, minus 4 plus 16 over x squared equal 6. So now to clear the fraction, let's multiply everything by x squared to clear the x squared at the bottom. So x to the power 4 minus 4x squared plus 16, x squared cancels, equals 6x squared. Let's move the 6x squared on the left hand side, combine the like terms. So it's x to the power 4 minus 4x squared minus 6x squared, opposite, then plus 16 equals 0. So this is x to the power 4 minus 10x squared plus 16 equal 0. Well then use the x method. Type is, you can use also substitution too, So this is easy. We can just in fact as is too. So this is negative 10. Well, then you're a negative 8, negative 2. These are the factors. So then the x squared minus 2 or 8, doesn't matter which one write first, is minus 8 times x squared minus 2 equals 0. Use the zero product rule. So the x squared minus 8 equals 0 or x squared minus 2 equals 0. So the x squared equals 8. Well, then x squared equal positive 2. So x squared, x equals plus or minus the square root of 8. So the x equal plus or minus 4 times 2. X equal positive or negative 2 root 2. That is the first two x values. And the other one is the x equals positive or negative the square root of 2. That's your two other x values. So we have 4 x values. So that's how we solve for x. Now we have to go back and substitute. So into y. So we're going to write the same equation 4 times. So here, because we have 4x values, so here is the y equals, so here first one, y equals 4 over x. So that was our so here, this is the one we're using here, right here. Okay. y equals 4 over x. Y equals 4 over x. And y equals 4 over x. Because we have 4x values, we need to substitute to solve for the corresponding y values. So the first one, let's plug in x equals, so let me use this, 4 x equals 2 root 2 positive, then y equals 4 over 2 root 2. Well, then this is the same as 4 divided by 2, this is the 2 root 2. Well, then if you rationalize the denominator right here, multiply root 2, root 2. So this is 2 root 2 divided by root 4. This is 2 root 2 divided by 2. 2 and 2 cancel. So the y equals root 2. That is your y value when x is 2 root 2. Let's do the same thing when x is negative 2 root 2. So here 4 y equal x equals negative 2 root 2, and then y equals 4 over negative 2 root 2. So the y equals negative 2 over root 2. So then rationalize again. So this is y equals negative 2 root 2 over root 4. Well, then y equals negative 2 root 2 divided by 2. So 2 and 2 cancel. Y equals negative root 2. So this is the value when x was negative 2 root 2. So let's keep going. We have 2 more values now. X is root 2 and x is negative root. So here 4 x equals root 2. So then y equals 4 root 2 over root 2. Rationalize it. Multiply top and the bottom root 2. So this is 4 root 2 over root 4. This is y equals 4 root 2 over 2. And 4 divided by 2 is 2. So this is 2 root 2. So this is the value of y when x is positive root 2. Next one is 4 x equals negative root 2. Then y equals 4 over negative root 2. And then this is rationalized, use name on the top. So this negative use on the top. So this is basically it's same as this over 2 root 2, 4 over 2 root 2. So root 2, rationalize it, y equals negative 4 root 2 over root 4. And then y equals negative 4 root 2 over 2, which is y equals negative 2 root 2. So this is your, okay. So now we are ready to write the solution set. Okay. The solution set is okay, so when x was, it doesn't matter the order. So when x was 2 root 2, the corresponding value was root 2. When x was negative 2 root 2, the corresponding value was negative root 2. When x was root 2, then the y value was 2 root 2. And then when x was negative root 2, which was last one is negative 2 root 2. So all these are the solutions. Make sure all these. So we have how many solutions? 1, 2, 3, 4. Okay, so a little longer, but it's not that complicated. So just try it. Mostly it's your the algebra. That's how we solve combination of both. We can do one more. What if there's the absolute value involved there? So then we can use the substitution again. So let's do one more. So here is a non-linear systems. With absolute value. Okay, so here is a quick example. Is this solve x squared plus y squared equals 16. That's number one. The second one is the absolute value of x plus y equals 4. They're both non-linear systems. So in this case, we can eliminate two, but I think the easiest way is to substitute. So isolate. So number one, you know what? Let's do side by side, make it much easier. Like this. So write this way. X squared plus y squared equals 16. Because you can go back and forth, make it so much easier for the substitution. So there's a y equals 4. So we're going to isolate here the absolute value isolated. It becomes 4 minus y other side. So that's the value we're going to plug in. So remember also the absolute value of x. So x is the same as, so x squared is the same as what? Absolute value of, this is the same thing because x is just positive. So this means we can easily replace x. X is same as the absolute because square is always positive. So we're going to replace this x here replaced by 4 minus y. Okay, so make sure it's the two terms binomials, use the parentheses. 4 minus y squared plus y squared equals 16. Open the square. This is now a minus b squared, which is what? A squared minus 2ab plus b squared. Well, that's the formula we're using here. So then this is 16 minus 8y 2ab plus y squared plus y squared again equals 16. So these three terms are coming from when you open the perfect square. So let's write it in descending order. Y squared plus y squared is 2y squared. So these are, this one here, yes, your perfect square trinomial. So then 2y squared minus 8y plus 16 minus 16 other side, bring it. So this is, they become 0. So it's 2y squared minus 8y equals 0. Binomial, take the greatest common factor out. So the 2y inside is y minus 4 equals 0. So either 2y equals 0 or y minus 4 equals 0, and then y equals 0. That's the first one. And y equals 4. That is the second one. So now you can go back and substitute. So write that. So I'm gonna plug in the first one. So here we're gonna go back. Let's try it. So let's use number 1 to substitute. So the first one, x squared plus y squared equals 16. That's the main equation, so we're going to use that's number 1. But then xy is 0. So then if it's so for y equals 0, x squared plus 0 squared equals 16. And then x squared equals 16. X equals plus or minus square root of 16 is 4. Or we can just go 16 like this. Make sure you're not confused. So it's x equals plus or minus 4. So for y equals 0, we have two x values. So it's going to be 0, 4 and 0, negative 4. I'm sorry, other way. So x always first, 4, 0 and negative 4, 0. So right here. When you write, so, okay. The next one is the 4. So again, write x squared plus y squared equals 16. Same equation. So for y equals 4. So this is x squared plus 4 squared equals 16. Then x squared plus 16 equals 16. X squared equals 0 because 16 other side become minus. So the square root of 0 is 0, so we're at 0 only once. So x equals 0. Okay, let's write the solution set now. Okay, so this is the here. Let's try this one. So 4 x is for this one here. 4 comma 0, negative 4 comma 0. Okay. Well, then we have x equals 0. The other one is 0 x is negative 4. So it's the 4, 0. The other one is 0 comma 4. So the last one is the 0. And then the y was 4. So there's only one coming from there. Okay. So here, this is 4 comma 0. And then negative 4 comma 0. Well, y is the 4. When y was 4, x was 0, so 0 comma 4. So this is the solution set.